feel free to ask them. Intermolecular forces. So these are forces of attraction and repulsion that can take place between molecules that are moving around. So on your lab, we had 6 different liquids with 6 different types of molecules that we were studying. And so there are 3 different types of intermolecular forces, main types. So first, the definition: intermolecular force would be the force of attraction between, or repulsion, so there's 3 things that affect how molecules either attract or repel one another. Okay? And so that's what intermolecular force is. It's just, it's kind of like gravity. You got 2 objects, pretty good size. There's a force of traction between 2 objects, and that's gravitational force. Okay? This is a different type of force, and it can be repulsion as well as attraction. But the main thing we're going to talk about is the attractive force. Okay? That means they're pulling together. They want to be pulled together. So there's 3 things we'll look at here. Okay? The first one depends upon the size of the molecule. Remember, last chapter you guys had questions dealing with boiling point. And what does the boiling point of an alkane depend upon? Longer chains, what do you know about their boiling points?
Longer chains,
higher boiling points. Okay? So, let's take a look at our lab and look at evaporation rates. So, which liquids will tend to evaporate quickly? Ones with long carbon chains or ones with small carbon chains?
Long.
Small. Because the longer they are, the more tendency for them to hold together. Meaning they'll stay in the liquid form and they don't want to evaporate. So the longer the chain, higher boiling point, and less likely they'll evaporate. So when you look at your list of temperature changes, which liquid on your list of those 6 had very little temperature change? Which was the number 1 molecule that didn't change a whole lot? Butanol. Butanol should have changed very little. Okay? Any questions? So we would say, looking at that results, that butanol...
No, methanol.
No, it's butanol. It should be.
I got it 24.6 and 24.2.
Okay? That one should have showed a little bit more. Okay? So butanol would have been the one, according to the way they should go, butanol would have had the least change. Okay? And so it has longer chains than those other alcohols. You look at methanol, 1 carbon long, ethanol, 2 carbon long, propanol, 3 carbon long, and butanol, 4 carbons long, has the least change. Okay? But there's also this thing called the hydrogen bond in there we'll talk about. Okay? So which one of those 6 had the least attractive force, and they evaporated really fast? In fact, they dried within a matter of a couple minutes. Pentane. Pentane had the biggest temperature change. Okay? And so it had the least attractive force. For some reason, it did not hold together really well. Where butanol held together really well and didn't want to evaporate. Okay? So when you have questions to answer, what you're going to look at is that evaporation rate. The faster it evaporates, the bigger the change in temperature. It doesn't hold together real well. It doesn't have very good attractive forces. Okay? Real quick, we're not going to give a whole lot of explanation of why, but more give you the 3 types of intermolecular forces. We're not going to get into the theory behind why these 3 do what they do, but we'll give you 3 different ways in which We can look at attractive forces seem to be stronger. All three of these are present versus not maybe two or one of them present. Okay? So, the types. Cooper. Number one. The first type, and the one that's really you're going to have a lot of when you look at the length of the chain versus small versus large, is going to be what's called London dispersion forces. It's kind of a weird name, I know. And all I'm going to tell you on this is it's the length of the chain that determines that. So the longer the chain, more London dispersion forces. Shorter the chain, less of them. Meaning those forces of attraction due to the length of the chain will depend upon how it holds together. Okay? We could go ahead and say that longer chains, greater dispersion forces. Okay? Tyler, are you writing this down? You need to write down on a separate notes so you have them, so that if we got a quiz over them too, you have it.
We can't keep these?
Yeah. Well, I'll have to grade them and give them back, and by the time I give them back, I might not. You can transfer it later. Okay? So London dispersion force depends upon the length of the chain. So the longer the chain, for some reason, they tend to be more attractive for one another. We're not going to get into specifics about that and the reason why, but that would be one. Okay? Now, looking at your chart, there's another type of bonding it's called an intermolecular force. What was the last column on there that you had written down if it had what was present?
Hydrogen.
Hydrogen bonding. So the second one is hydrogen bonding. So alcohols have hydrogen bonding, and that means that they will tend to have stronger intermolecular forces. Now, we're not going to explain why they have hydrogen bonding, get into specifics about that. But if it has an OH group, which is an alcohol group, they tend to pull together better than if you don't have it. So if you have OH, or you have, and this would be an example, hydrogen bonding alcohols have that, they tend to have greater attractive forces. Okay? So let's look at a trend of your alcohols. Which one, we already probably know which one it is because it was already stated, which alcohol changed the least in temperature because it evaporated more slowly? Butanol. We already came up with that, butanol. Which one evaporated quickest of the four? Which one? No, just the alcohols. Just the OLs.
Oh.
The quickest?
Yeah, which one? Methanol. Methanol evaporated fast because it had the biggest change in temperature. Okay? So that would be, the one would be the greatest, would be the least attractive force. And that kind of goes with length of the chain. So they're all alcohols, but if you look at the length of the chain, smaller length evaporates fastest, and the longest length evaporates the shortest. Do they go in order? methanol, ethanol, propanol, butanol. Look at your changes of temperatures. Look at the one that changed the least. We said it was butanol. The one that was most is methanol. Is ethanol next on your list in change? No? Is propanol changed more than ethanol?
Yeah.
Should be ethanol, should be next. And then propanol should be a less of a change than ethanol. And then butanol should be the lowest change, because it evaporated the slowest. That should be the trend when we look at just the alcohols. Okay? You might have to subtract them again just to make sure. Alright? The third one really doesn't play into our lab. And I'm going to give it so you have it, but we're really not going to talk about it when it comes to our lab information. And the third one is if we have a polar molecule. So I'm just going to leave it at that. Polar molecule means one side slightly negative, the other side slightly positive, for example. Like water is a polar molecule. Because this side of the molecule is going to be negative, and then this side is going to be slightly positive. So water is polar. Okay? So that's really all you need to know. We probably don't have many questions with that. More looking at hydrogen bonding. If it has an alcohol, it's going to have greater forces. And if it has London dispersion force, meaning longer chains hold together better than shorter chains. And so wanted to finish up those ideas involving the lab. Okay, any questions you have?